Good morning. Today we will see the design of program 1B of design and analysis of algorithms laboratory. The aim of the program is to create a Java program to implement the stack using arrays. So as we all know that a stack is a data structure which is a collection of homogeneous elements where the insertion and the deletion can be made at one end called as top. So we have to now write a program to implement certain methods which demonstrate the working of the stack. And the methods that demonstrate the working of the stack is push, pop, and display. So push is a method which allows us to insert element into the stack. Pop is a method which allows us to delete an element from the stack, and display is a method which allows us to display the contents of the stack. And as we all know that the data structure stack follows the method of LIFO, that is last in first out. The element which is inserted last will be the element which will be popped out first. So last in first out, LIFO technique. So now let us see how do we implement the stack using arrays in Java. So we need to import the package java.util and extracting or importing the class called scanner. So again we have two classes. One is a class stack and another class called as the main class called as class stack demo. So before me going for the main class or the main definition, let us now define what does a stack contain. So as we are implementing the stack using arrays, so we have certain variables to be declared. First is the size of the stack. What is the size of the stack that you want to demonstrate? And an array. So and also we are demonstrating the working of the stack using an integers, stack of integers, an array which holds the elements or which works as a stack for me. So right now I've just declared an array, so which means to say it is just a variable which was just acting as a reference to a array of integers. So still I have not allocated any memory for this array. That is, it is having now a null reference. It does not hold any valid reference, which is now valid reference of memory of n integer objects. It's an array. So next is a top, which is of type int. So I need to implement push, pop, and display methods in the class stack. Before that, I need also to implement an constructor. What is the job of the constructor? As we all know, it is to initialize the data members. So what are members that I need to initialize? These are the three data members, that is the size, the array, and the top. So let me now initialize the top. As we all know, the top will be initialized to -1. And creating an object SOBJ of the scanner class and asking the user to enter the size of the stack, and that will be stored in the variable size. The next job, once I have read the size of the array, which stimulates same as that of the stack, I need to allocate memory for the array. So AR is equal to, I need not have to again declare it. So you should not declare it again. Just use the variable name ARR and allocate the required amount of memory. What is the required amount of memory that I need? It is of size. So it will allocate the required amount of memory of type of how many blocks? The size block. Say for size is 3, so it will allocate the memory to hold 3 integers. So how do I do that? New, use the keyword new, then the int, and then in the parenthesis use the size variable. So this will now create a top with initial value of -1 and the size which is read from the user. Based on the size, we allocate the memory for the array too. Next is to define the method. So that's the push method, pop method, and display method. The push method is something like this. So it does not return anything to me, void, and it takes one argument, that is item, which is the item to be inserted into the stack. So as we all know, when we are dealing with the push method or the pop method, we need to encounter the conditions such as stack overflow as well as stack underflow. What is stack overflow? Stack overflow is a condition wherein we try to insert an element into the stack when the stack is full. And stack underflow is a condition wherein we try to pop an element from the stack when the stack is empty. So how do I know whether the stack is full or the stack is empty? It is based on the variable so called as top. As we all know that the top initial value is how much? -1. So when can the top tell you that it is the array or the stack is full is when top is equal to size -1. That is, top equals to -1. That is, I am now starting with 0 and goes on till size -1. The size of the stack will be from 0 to size -1. So continuing now with the push operation, let us see how does it work. If the condition is now the top, the variable top is less than size -1, right? That means to say my top is pointing from 0 to size -1. If it is pointing to less than size -1, that means to say I can accommodate an element into my stack. So how do I accommodate an element into the stack? First, update the top pointer, because we should be knowing that the top will always be pointing to the topmost element onto the stack. In order to add an element onto the stack, we need to first upgrade top by 1 position. So up top plus plus. And then at the updated position of the top, I need to place the element into the stack. So array top equals to item. And I am giving a message, the item is pushed into the stack there. That is when top is less than size -1, because my size of the stack is from where? 0 to size -1. So size less than size -1, that is, it will accommodate when top is less than size -1, I can accommodate an element into the stack. But when top is equal to size -1 or greater than size -1, means to say that top is already, when top is equals to size -1, means to say it's already occupied the last position in my stack. That means to say the stack is full. It's already occupied all the positions in my stack when top equals to size -1. So if at all the top is equal to size -1, that does mean to say it's not less than size -1. You mean to say there's an error, that is you're trying to insert an element into the stack which is full. That is, you give an error message, that is stack overflow. So very simple aspect. If top is less than size -1, yes, I can accommodate my element into the stack. But when top becomes size -1 equals to size -1, we cannot accommodate the element into the stack. Next, the design of the pop method. Obviously, the pop method we have to check for the counter where the stack is empty and trying to delete the element. So when is the stack empty? When top is equal to -1. When top is equal to -1, they give a message stack underflow. Else extract the element, means to say delete the element from the stack. That means to say you will have to first get the element at the top position, that is array of top equals to item, store it in another variable called as an item, print what is popped out of the stack, that is array of top is been popped out of the stack or the item is popped out of the stack, then decrement the pointer top. So in push you will have to first increment the pointer top and then assign the element at array of top, whereas in push you will have, what you have to do is first extract the element which is at the topmost of the stack and then decrement the top pointer. Why? Because top will always point to the topmost element in the stack. That means to say the last element which is inserted onto the stack. So you will have to extract the element using the top variable and then you will have to decrement the variable top. Whereas here you will have to increment the top variable, then insert the element at the top of the stack. Right? Then comes the display method. So display method, if at all the top equals to -1, tell that the stack is empty, else print the elements in the stack that is ranging from 0, I equals to 0, because 0 indicates, the index 0 indicates that is the first element which is inserted into the stack, and the index top indicates the last element which is inserted onto the stack. So I less than or equal to top. Never use less than size, but it should be top here, less than or equal to top. I plus plus, print the element of the arrays, that is AR of I. Next is the main method. So we'll have to now first create the object of the stack class. S is an object of the stack class, and variable X, and object SOBG is an object of the scanner class choice, because I'll have to run through the different options in the stack. So system.out.println, press 1, the choice method, 1 to push, press 2 to pop, 3, 4 to exit. So I'll have to repeat this process of entering the choice for several times. So I'll use a do while method. So do, enter the choice what you want to perform, and that is read in ch. So I use a switch case, switch ch. Case 1 is to call the push method by entering the element that has to be pushed into the stack. So asking the user to enter the element which is stored in the variable X. Then call the method push by using the object of the class stack s dot push X. Then the break statement. Case 2 is calling the pop method s dot pop method and the break statement. Case 3 s dot display method, the break statement. Default other than k 1 2 3 option given, any other option given, invalid choice, then the break. The end of the switch, and then this continues reading the inputs while ch is not equal to 4. That means to say, if you give the choice as 4, the program just terminates. And is the end of your main method and the main class. Let us now see how the execution goes here. So I have the same program here. Let us now execute the during the execution, the user will prompt to enter the size of the stack. So for example, I enter the size of the stack as 3, and the options is 1 2 3 to push, pop, and the display, 4 to exit. So I enter the element. So I enter 12. So 12 is pushed onto the stack. Next again 1. I give 23. 23 is again pushed onto the stack. Say for example, I give another choice 1. Say 25 is also pushed onto the stack. So you can now see I have already pushed 3 elements onto the stack. Pushing the next element into the stack definitely should give me an error, that is the stack overflow, because I'm trying to insert onto the stack and the stack is full. Giving the choice 3, now display the elements in the stack, that is 12, 23 and 25. So pop, next choice is 2, so it will pop the last element which is inserted into the stack. The last element which was inserted into the stack was 25, so it will pop 25. Next again pop, it will pop 23. You can see 23 is popped out of the stack. Entering 2, again it will tell 12 is popped out of the stack. Next entering 2, it will tell that the stack is underflow. So this is how the program will now execute with respect to the stack. So the main intention or the main aim of the program is to simulate the working of the stack by using arrays and illustrating the operation push, pop and display. Thank you.